using orthogonal vectors can help us in a physics class because we know if we have the vector 2, -3, we said we could write that as 2i minus 3j, where I is the unit vector in the x direction and j is the unit vector in the y direction. And we said we need it to be 2 units long to the right and 3 units long going down. But maybe I have an incline. Maybe I have a force, whoa, that's going straight down, we'll pretend, on toward the earth. Okay, so I have something sitting here that I want to keep it from sliding down the hill, or maybe I want to pull it up the hill. But it's exerting a force straight down to the earth. So I want to talk about that force in terms of 2 orthogonal vectors, meaning this force straight down can be broken into a component in the direction parallel to this ramp, or the incline that's going up, and then perpendicular to that. If I want to write a vector as 2 orthogonal vectors, up a hill apparently, then we can, where these orthogonal vectors are not horizontal and vertical, I mean those are the simple ones, we've got 1, 0 and 0, 1, and we can make those as long or as short as we need to point in the direction we want. But we can make W1 in any direction that we want to, parallel to some vector that we're working with. Okay, we call this the projection of U onto V. Okay. And our W1 is going to be, I want to say parallel to V. Okay, so we want to break it into a vector that goes in the same direction, either up or down, but parallel to our incline, and then we want one that is perpendicular to it. I'm sorry that this is so atrocious. Once we know W1, then we can subtract the 2 vectors because we want W1 plus W2 to be our U. And so if I need to solve this for W2, I can just move the W1 over. Okay, so then the next thing says, well, how do we do that? How do we project a vector onto another one? Okay, so if this force is our U, we want to project it onto this incline. So we have a piece going this way and then a perpendicular piece going that one. Okay. Which, by the way, that incline was a separate thought from this vector here that we were using in the last video. Okay, so here's my vector U. And maybe for some reason I didn't use the V that we were using before, but maybe I need to break it into components, orthogonal components, where one of them is parallel okay, I can't read my writing, to the vector 3, 1. Alright, so let's see if I can get even a reasonable graph here. It doesn't look like it, so I'm going to use my computer assistance. The embarrassing part of this is I have my computer so far away from me so I can read it, but then these little things, I can't read it all. To read my own handwriting, it's like halfway across the room. Okay, and I am going to tick these off 1, 2, 3, 4, 5 this way, so we don't have teeny tiny little marks that we're working with, except I missed there some way. I apologize for the delay. 3, 4, 5. Okay, phew. So the vector 2, negative 3 is going to go to the right 2 units and down 1, 2, 3 units. And it's going to end about right there. I didn't get a point on him, so I'll do that later. And we said 3, 1 is the direction that we want to go in for the other one. I'm going to pause this and make it look like I want to without wasting your time anymore. Okay, so my u vector is this one here. Okay, this is my vector u. My vector v, I made green. Okay, and we said we want to break u into 2 components. And this guy's almost like perpendicular, but they're not. They're not perpendicular. That's not a 90-degree angle. So what I'm going to need to do is find a way to break u into a component that is perpendicular, one that's parallel to v, excuse me, and one that's perpendicular to v. So my w1, if I can sneak a little arrow in here, would be the vector here going in this direction, and w2 would be this piece. Whew. All right, now having said all that, if I want to project u down onto v, the formula for getting that done looks like the dot product of u and v over the magnitude of u times the magnitude of v. Okay, this is a scalar value. This is going to be a numerical value. And so this gives us the length that we're going to scale v. So again, this is a numerical value. It's a scalar. And we'll take that times v to stretch it or shrink it in the right amount. So we end up with just this little piece, w1 here. Once we know w1, if I want to write u as w1 plus w2, then I take u minus w1 to get w2. So if I want to project u onto v, I want to find that w1. My dot product of u and v would be 6 minus 3, which is 3 on the top. We said earlier that the magnitude of u is the square root of 13. The magnitude of v is going to be the square root of 10. And I lied about this formula because my eyes went to the wrong formula. I knew this didn't feel right. I should scrap this video and start over. I wonder if I'm... This instead should be the magnitude of v squared. My eyes went back to that stupid cosine formula that I had next to it, and yes. So instead of square roots on the bottom, which I don't like, the magnitude of v is the square root of 10, so I'm going to have a 10 down here. And my w1 is going to be 3/10 the length of regular v. That means my x component is 9 over 10, and the y component is 3 over 10. Alright, so if I want to find w2, I take u minus w1. And maybe I don't like fractions, but I'm going to live through this example. 2 is 20 over 10. 20 minus 9 leaves me 11 over 10. Negative 3 is negative 30 over 10, so negative 30 minus 3 more is negative 33 over 10. Now remember what we were doing here is we were creating 2 orthogonal vectors. w1 and w2 should be perpendicular to each other. Okay, what I'm going to do is I'm going to prove that to you because we know that two vectors that are perpendicular should have what if we find their dot product? What should their dot product be? We should get 0. So if we take 9/10 and 3/10 and take the dot product of that with 11/10, negative 33/10, okay, that dot product says 99 over 100 minus 99 over 100, which is equal to 0. Okay. Those guys really are orthogonal to each other. We also, the way that we created these two w's, if we add them together, we should get what? We should get u. Now, 9/10, 3/10, if we add that to 11/10, negative 33/10, and this is kind of cheating because even if we made a mistake right here, but did our work correctly right here, then we're still going to think that they add up to be what we want them to be. Okay, but 9 and 11 is 20 over 10, which is 2, and 3 minus 33 is negative 30 over 10, which is negative 3. Okay, that's what we wanted it to be. Okay, so mainly this is the check. You can check for orthogonality. When I did this before I started the video, I had made a mistake somewhere, not unlike what I did up here when I wrote down the stuff wrong. Okay, I have one more example, but this video has now gotten way out of hand. But we're gonna do one more example of this once this video uploads.